video is about how to solve systems of linear equations using an algebraic process called elimination. Remember, a system of equations is really just two or more equations, and we're going to stick with linear equations for this video. We know that if we can graph these, we would see two lines, and the solution to a system of linear equations would be where the lines intersect, if they intersect at all. Of course, if they don't intersect, the lines are parallel, there would be no solution to the system. So if we graphed it, we could find that point of intersection, and that point would represent the solution to the system. This system we're going to try to solve without graphing. We're going to just use algebra. Notice we have a negative 5y in the top and a positive 5y in the bottom. Those terms are opposites. That's kind of nice to have a setup like that, because I know that if we add opposites together, we get 0. So if we added these two equations together right now, the y's would eliminate. And that's exactly what we're going to do. We can actually add the top equation to the bottom equation. And it's okay to do that, because we have an equation at the bottom, 7x plus 5y equals 25. So we can add 7x plus 5y to 2x minus 5y, and 25 to 20, and it keeps the balance of the equation. Because these two things are equal, we can add the corresponding left-hand sides and the corresponding right-hand sides. It's mathematically okay to do that. When we add these two equations, we get 9x plus 0y equals 45. The negative 5y plus 5y made 0y. Well, this is really just 9x equals 45, so x must have been 5. Remember, the solution to a linear system is really an ordered pair. We need a y-coordinate to really find the point where these two lines intersect. We have the x-coordinate already. To find the y-coordinate, we can just plug back in to one of the equations. So let's plug in to, it doesn't matter, I'm going to pick the top equation just because the coefficient of the x-coordinate is smaller. I like smaller numbers. 2x minus 5y equals 20. And that gives us that 10 minus 5y equals 20. Negative 5y is 10, so y must have been negative 2. So we have our x and our y coordinate. If I wanted to write the answer as an ordered pair, I could write it as 5, comma, negative 2. And that's the solution to the system. That's the point where those two lines intersect. Let's look at another one. This system has a similar setup as before, but notice we don't have that nice opposites that we had before. We didn't have a negative 5y and a 5y. Notice we do have a 6x and a 2x, a negative 5y and a negative 3y. If we're going to use elimination again to try to eliminate a variable, we need opposite terms. The easiest way to do this, I believe for this system, is to multiply the bottom equation on each side by a negative 3. Think about why I picked negative 3. I wanted to turn this 2 into a negative 6. Then we'd have a 6x and a negative 6x. What would we multiply 2 by to get negative 6? That would be a negative 3. But if you're multiplying one side of the equation by negative 3, we have to multiply the other side of the equation by negative 3. What we would get when we distribute is negative 6x plus 9y equals positive 33. I'm just going to rewrite the top equation right underneath to keep my work organized so I can really see what lines up. Since we have opposites now, I know that one variable will eliminate when we add, and we get 0x. 9 plus negative 5 is 4. Y equals 12. 33 plus negative 21. So 4y equals 12. That means that y equals 3. We're not quite done. We have to find the x-coordinate. And let's plug in. It doesn't matter. I'm going to pick the bottom equation this time to plug back in. 2x minus 3y equals negative 11. That was from the original equation. I just substituted 3 in for y, and now I have just one variable, and I can solve for x. 2x minus 9 equals negative 11. If we add 9 to both sides, we get that 2x equals negative 2, so x is equal to negative 1. If we wanted to write our answer as an ordered pair, we would write that as negative 1, comma, 3. If we were to graph those lines, that's the point where they would intersect. With elimination, our goal is to eliminate one variable. Sometimes it's easier to eliminate x first, sometimes it's easier to eliminate y first. It's going to take a little bit of practice to figure out which one is going to be easier to eliminate. In this example, we had to multiply one equation by negative 3. It might be that you have to multiply each equation by something in order to eliminate a variable. So it might take quite a few steps, but you should always be able to eliminate a variable and then plug back in to solve for the other variable. Good luck!